Lesson 4, practice 4. Let's get right to it. So there's a little summary, basically tells you what we did today. It talks about the scale factor and how you know, depending on what the scale factor is, if the figure, the copy, was enlarged, reduced, or stayed the same. If the scale factor is less than 1, the copy will be smaller than the original. If it's equal to 1, the copy will be the same size as the original. If it's greater than 1, then the copy will be larger than the original. So let's take a few examples here. So here are 4 rectangles and they're scale copies of each other. So they're talking here about P2R. So they talk about this. What happens if you take this rectangle and change it to this? Well, it got enlarged, got bigger. So if it got bigger, it's definitely, the scale factor used was definitely greater than 1. Q2S, so from Q2S you can clearly tell it's a reduction. So if it's a reduction, the scale factor is going to be less than 1. What about Q2R? Q2R is also an enlargement. It got bigger, so the scale factor has to be greater than 1. Okay. We have 2 here, so let's see what's the scale from S to P. From S to P, they're both identical rectangles, so no changes in size. So the scale factor that we'll use is equal to 1. From R to P is a reduction, right? It got smaller, so the scale factor used has to be less than 1. Triangles S and R are scale copies of one another, so somebody did the job for us. So what was the scale factor that they used? Well, so from S to L, that's our first question. So from S to L, you notice that's an enlargement, right? We need some numbers. So the number, let me use the bottom here because it's always the easiest. So the base is 2, and the base here is 4. So scale factor, when it's an enlargement, we're going to use a little formula, big over small. You use these 2 corresponding sides, the 2 and the 4. The bigger number is 4. Small number is 2, and 4 over 2 is the same thing as 2. So the scale factor that they used was of 2. And that makes sense. You can clearly tell, like, look, 2 times 2 is 4. So over here, we're going to put 2. It got bigger by 2, right, by a factor of 2. Now, what if we were to reverse this and go from L, right, back to S, back to the original? What's the scale factor that I would have to use? Well, I would have to, well, we know that going from S to L, which was the enlargement, it got bigger by 2. So going back to the original, we're going to use the reciprocal, right? That's the word we use today. And it's going to be a half. 5. Okay, so now there you have another triangle here. So imagine the triangle M. So they did S and they went and they created a triangle here. And they use a scale factor of 3 over 2. 3 over 2, if you want to think of it as 1.5, right? It helps. So we know that from S to this triangle that they didn't draw for us, unfortunately, this triangle M is a bigger triangle. And the scale factor was 3 over 2. It got bigger, right? That's how I know it's a bigger triangle. Now, what if we went, they asked, hey, take the copy and go back to the original. What's the scale factor that would take us back to the original? Well, if going there was 3 over 2, going back, right, it's going to be a reduction, and it's just going to be the reciprocal of whatever the scale factor that got us there to begin with. So in this case, 2/3. Okay, so here is a polygon, right, that has a certain perimeter. Let's find it. Let's give some numbers. That's a 3, that's a 3, that's a 3, this is a 6, this is a 3, and that's a 9. Right, so currently 3, 6, 12. No, sorry. Where's the eraser? Is the eraser? This is a 6. So currently, if you were to take your dog around this shape, the perimeter would be 1830. They want us to draw a scaled copy of this, so it has to be the same shape. But in the new shape, if if I were to take my dog for a walk around the shape, the perimeter should be 10. I am going to reduce this by 1/3. Not by 1/3. I'm going to use a scale factor of 1/3. Right, so it's going to be a reduction, right? Obviously. And the scale factor that I'm going to use is 1/3. So 3 times 1/3 is just 1. 3 times, so everything that's a 3 is going to be 1. Everything that is a 6, what's 6 times 1/3 is 2. That becomes a 2. This 6 times 1/3 also becomes a 2. And 9, and 1/3 of 9, what's 1/3 of 9? It's just 3. Right? I use 1/3 because it can't be any other, right? There's nothing else that would divide nicely, and I don't think it would give us a problem otherwise. So if I add up the perimeter now, so this is 3, this is 2, this is 2, this is 1, this is 1, and this is 1. 3, 4, 5, 6, 7, 8, 9, 10, look. It worked out. Okay. Let me erase. Did I just do this? Oh. So the scale factor that got us to the smaller polygon was 1/3. Now, what if I were to go from the smaller back? Right. So if I would, they asked me, hey, take this and enlarge it and go back to the original. Well, we would use a scale factor of 3 because that's the reciprocal of 1/3. Yeah. 8. Well, 2 squares always be scale copies of one another. So if you take a square, and take another square, will they always be square copies of one another? Yes, they will be. Okay, because they have identical angles. They have same angles. And their sides would always be proportional. Okay. The ratio of corresponding sides of any two sides, right? So if you think about it, let's give this some number. So let's say this was 2 and this was 2 because it's a square, right? And this was a 7 and this is 7. Okay, and I said, hey, on this side, right? Let's use the ratio of any two sides, so it just happens to be the same. And then let's use the ratio of the corresponding sides that we chose, right? So we chose this side and this side, which corresponds to this and this. Now, what's 2 over 2? 1. What's 7 over 7? 1. Are the ratios the same? Yes, they are. If you want to cross multiply, that's another way to check if they're proportional. 2 times 7 is 14. And what's that? 2 times 7 is 14. So no matter what number you use for the side of the square, it would always work. Figure B is a scale copy of figure A. So figure B is a scale copy of figure A. Okay, it's a scale of factor 5.5. What's the value of x? Well, figure B. So they went from here to here, and it's an enlargement. Yeah. And they use a scale factor, and they give it to us 5.5 or 5.5. We know that this is 4, so if on the smaller triangle that's 4, what's on the big triangle? Well, this to this times 5.5. So let's multiply. 5.5 times 4 is 22. So this guy here would be 22, right? They give us a scale factor. They give us that side's 4. The corresponding side on figure B would be 4 times 5.5, which is 22. Well, no, here, 10. What is it? Spiral. Select all the ratios that are equivalent to 12 over 3. Right? So 12 over 3 is the same thing as 4. Yeah? So let's keep that in mind. So, is 12 over 3 the same as 6 over 1? well, 6 over 1. So let's do it the quick way. 12 over 3, the ratio. Right, simplifies to 4. 6 over 1 simplified to 4? Does not. 1 over 4 simplified to 4? Does not. Does that simplify to 4? Does not. Is 4 over 1 simplified to 4? It does. 24 over 6 simplified to 4? Yes, it does. It's 15 over 6 simplified to 4? Does not. It's 1200 over 300 simplified to 4? Yes, it does. That's 112 over 13 simplified to 4? Does not. So, blah, blah, blah. I'm not doing that. And that's it. This one. Well, that's not bad.